a canvas black with whispers gold, stories untold, secrets unfold, diamonds scatter where the shadows sleep, infinite skies, a promise to keep. Beyond the lights where the stars collide, a universe vast where wonders hide. Above our heads, a cosmic dance, an endless dream, a fleeting galaxies were like painted streams, brushing the edges of our dreams. Planets hum their silent tune, chasing the sun, kissing the moon. We look but don't see, we forget to believe. Beyond the lights where the stars collide, a universe vast where wonders hide. Above our heads, a cosmic dance, an endless dream, a fleeting nebulas bloom in colors untamed. Every spark a fire unclaimed, hidden glory just out of sight. A quiet roar in the endless night. Beyond the lights where the stars collide, a universe vast where wonders hide. Above our heads, a cosmic dance, an endless dream, a fleeting
Wow, good early morning, everybody, and welcome to the stream. There she is, 3i Atlas, at closest approach to the Earth. Well, thank you and good night. No, I'm just kidding. Hello, Tim. Hello, Sally. And Civil Defense Bunker says, anyone tuning into a radio telescope to monitor the Skinwalker Ranch frequency of 1.6 gigahertz. Guess what? I don't think so. I don't think anyone's doing that. Yeah, so that's actually interesting. I have a new gear here, so I don't believe you're going to hear any buzzing in the background. So I think we're good. Kathy Messick's with us. Hi, Kathy. How are you? Nice to see you as well. Everybody here are the early birds, the veterans, the brave ones. You know, I think that's pretty cool. It's good to see you all. Let me do a little of this. I'm going to move this up here, and I'll move me up here as well. So that if I want to, I can just get in your face and come in here and say, look, there's the comet. You know? Anyway, I hope you guys are doing okay this morning. It's been kind of a long day and a half here. Yesterday, I had to go to New York City. I live in Connecticut. And I had to do some filming at A&E Studios. I've never been there before, so it was nice to go see that place. They always come to me for The Proof Is Out There, but this time there's another project that they might want to do, and they had me do some filming, and so that was kind of nice. Long ride, though, down and back. I mean, I haven't been to New York City since 2015, and it was absolutely not a pleasant ride down and back yesterday. So if they do this, I don't know how I'm going to deal with it. Anyway, we're having a good time, and oh, you're in Litchfield County, Torrington. Hey, guess what, Civil Defense Bunker? I'm in Terryville, Connecticut. I'm 12 minutes from Torrington, if that. Sometimes I go to the Torrington Home Depot. Yeah, he says he's working late shift, East Coast, waiting on the event. Yeah, no kidding. Yeah. So, the telescope is actually out in Benson, Arizona. So the telescope's 2,500 miles away. You know, but you know, it's what we expect to see. You know, if you want to use telescopes, you gotta use them in a dark sky, and that's a dark sky up there. Where I am and where you are, civil defense in Connecticut is not a very dark sky. Now you can see that the comet has an elongated nucleus right here. The reason for that is because it's at closest approach to us. So every movement that it makes in the sky will look like it's more exaggerated because it's closer to us. Things that are closer, flying through your field of view, will look like they're flying very, very fast. In this case, we can see this dragged out nucleus of the comet. I call your attention though to this area right here. See that? That's actually pointing right toward the sun, and that is what's called the antitail. And that's the thing that's been crazy for everybody here. You know, that they've been examining this comet. Now I'm going to do this. I'm going to bring you back because we have 13 stacked frames right here. I'm going to clear this, and we'll have another frame come in, and you'll see it round. You know? Yeah, hey, Mindfork is here. Hey there, how are you? Nice to see you. And then we have J-Boost. J-Boost is with us. J-Boost 2024. Nice to see you. Vernon, Connecticut. Nice. Terryville, Connecticut. Benson, Arizona. That's where the telescope is. That's telescope number 2. Telescope number 1's in the Sonoran Desert, 220 miles to the northwest, actually. There it is. Look at that. Now, we're also battling some light clouds. Let me show you that. So here you can see the light clouds. This is the direction we're kind of looking is this way. So we're actually about this high in the sky. Let me refresh it to show where we are now. Yeah, see, we got a little cloud bank coming through. That's a bird turd on their camera. I'm borrowing this camera. So we have high clouds, but we can still see it. I have my cloud filter on. Boy, do I wish I had one of those. Yeah. We're also getting wind in the morning. The wind kicks up a little bit, and so it drives our image a little nutty. But it's okay. We still get to see the comet. I'm going to save this like this. Remember, these photos are all available to you at skytourlive.com. You just go up there, or skytourlive.org even. You just go up here, and you can go down to I Want Cool Pictures, read the instructions, click on it, and go down to this location and grab them. So it's pretty cool. All right. So we've done 3 here. Yeah, we're watching it, man. This is live. You can see the effect of clouds, light clouds, kind of fuzzing the image a little bit here. But it's all right. So it's okay. Not a problem. We can deal with it. Okay, so I just turned up my volume a little bit. Yeah, you early birds, you get to see it. And this is 5 hours past closest approach. Now, at closest approach, it wasn't visible at that point. It was just barely visible. And then Degrader says, finally the clouds lit up. No kidding. Says, just walked out and saw it. Where are you? Where are you located? And he says, I've been up all night for this. But yeah. You have your own scope? You're checking it out? It's around 11th magnitude, which is, you know, you can see it. It'd be faint in a moderate scope. In a larger scope, it can be pretty bright, you know. We also have big news potentially on observatory number 3, and I'm going to hold off on saying much. All I can tell you is it's going to be a capability hundreds of times what we currently have, and that's due to a benefactor potentially, and I can't say any more until we know for sure. Degrader says, yeah, very faint. Southern Illinois. Okay, yeah, you got your telescope. Good man, good. Excellent. And Chris is Mind Fork. She's in Oklahoma. I know her. She is a bundle of energy, that girl. I'm telling you. What a nice person. And she asked, what really happened to Maven? That's a good question. First of all, there's a internet rumor out there that's internet bull, okay, and I'll call it like it is. You know me. That says that when it went around Mars, when 3i Atlas passed Mars, I think it was like, what, 60 million miles from Mars when it passed it, so it's not really close. The Maven spacecraft, the claim is it went down when it went past Mars. That's not true at all. It passed Mars in October, and it ended up coming all the way around the sun and past Venus, and that's when, in early December, I think December 6th, is when the Maven spacecraft quit. And it happened when it went behind Mars. Now here's what happens. These spacecraft are subject to intense heating when they're on the sun side of Mars, but then intense cold. So they're going through those cycles. And in this particular spacecraft's case, it was in orbit. So it was going around Mars lots and lots and lots of time. So what will happen is the extreme cold can eventually get to it. Just like happened with the Spirit and Opportunity rovers. The intense cold, in spite of our engineering, which is fantastic, wasn't strong enough to withstand those intense cycles of cold. Alright, I'm going to save this right here. We have 11 frames stacked. This is not exactly what that looks like. Remember, this is a stretched view because it's taking a picture, taking a picture, taking a picture, taking a picture, so it's stretching it out. The benefit is you see the tail, and you also see the anti-tail. See that? Yeah. It's moving that way, and it's moving away. It's moving into the page away from us at this point. So it's passing us. So it's going that way into the page, way away, away, away. Yeah, okay, let me clear that now. We'll bring in our next shot. I'm doing 30-second photos. Alright, you can see right up there. Now, the most important fields on this entire screen or the exposure time here. Oops, that was bad. Which is 30 seconds. Okay. What'd I do? I didn't like that. Okay, hold on. Let me go back to this. Okay. Exposure time is 30 seconds. Man, hold on. Let me fix this. Actually, I don't know if I should. It might look okay. And let's see, do this. Yeah. Exposure time right there is 30 seconds. That's a very important value. Okay. And then down below it, we have what's called a gain. And the gain right here is right now at 300. So it's a pretty high gain that we're using right now on this. And that gain is a value that will allow us to see the image a little brighter, and it increases the sensitivity of the sensor. And that's the thing that we're doing right now, is that. All right. So that said, those are the two most important fields on this entire screen. Right. So let me fix all this. I don't know what happened here. I know what happened. I'm also half asleep because I got home from New York City, from A&E Studios, and I ended up out in the internet world, looking at a few things, getting ready for tonight's stream, to this morning stream, and before I knew it, it was 1 a.m. So I was like, okay. Oh, but I had to do a show. I was on the Clyde Lewis show, Ground Zero Radio, from 11 to 12, and slightly longer, and then I could go to bed. So I ended up getting to sleep around 1 a.m. Got up at 4:45 to come down here and get all these things straightened out, make sure everything was working fine, and it is. So this was all good. Yep. So here we go. This is our comet. We have 5 stacked here. I'm going to save it. And these will all be available to you. Now, I want you to notice something really important, okay? I want you to watch, taking me out my email with it. I want you to watch that star right there. See that star? That little guy? That little guy is going to be very important. I want you to watch the nucleus relative to that star. And I'll tell you why. When we look at comets, we can actually see their movement in the sky. And that comet started over here earlier tonight, right around here. Okay, and now it's here after just a few minutes. It's also moving its fastest relative to the background stars at this point, because it's the closest it is to the Earth, so things that are closer to you seem to move faster. So now let me I'll just save it one more time. Now what I'm going to do after all this is I'm going to put this together in a animated file, so you'll actually see it moving through the sky. I'm going to do lots of these images, so we're going to get it traveling through here. And we're not going to move the field at all. We're going to let that stay there so the stars are in the same place, and this will just be moving through. Okay? So it's going to get probably down to about here, And it's also 4:22 in the morning out there. So we have more time before sunup in Benson, Arizona. And Degrader says, thunderstormed hard, rain, snowed. Snow's going to be, and now it's going to be 76 today? Really? In Illinois? Jeez. Man, I'd like to do that. Seth360. I don't know what the number is after your IDs. Anyway, I don't know what that is, but Seth's telling us what he's doing. Melissa's with us. Melissa Gland, how are you? What do you think it is? And I think, here's the thing, okay? I'm going to clear this, by the way, and let us get another one. Okay, here's the deal. When it first came out, a bunch of shows asked me to come on and talk about it. And at that point, I had only photographed it when it was out at the distance that Jupiter is from us. And it was a tiny little line of a dash of time, like we see it moving. But it's much, much smaller. Many, many minutes would pass before you would actually see there was motion to it. Okay? But now we have this motion. See these little extra dots here? That shows that even though the telescope is guiding, which I'll show you. Yeah. It's guiding through a cloud right now. There's a little cloud, so it's a little tough for it to continue guiding. So that's going to come and go. So what was I saying? I'm probably not thinking straight tonight. Blocker's with us. Hey, Blocker. Yeah. John Smith says, "When's it coming to Earth?" It's already here. What you're seeing in the sky right now, that's as close as it's gonna get. Note this reddish hue here. This is the pre-dawn light affecting the light clouds that we're watching this through. So when it first came in, I figured this has to be an object that is interesting to us because we've never seen an interstellar object like this before. It was doing some really strange things. Like in the very beginning, it had this excess of nickel atoms that were coming off of it. And that excess of nickel was a fascinating discovery because when we see nickel, we expect to see iron. Iron's number 26, okay, in the periodic table. We expect to see we expect to see nickel as well. Well, unfortunately, we didn't see any nickel. Didn't see any iron. And so this lack of iron was troubling because it made it look like there was just this nickel, and we don't expect comets to show us nickel without iron. So that said, we had to look at the data and try and figure out why we were seeing that. Now, there is a theory, which I will tell you. Clearly, there is nickel and there is iron out there in the universe and in comets, okay? Well, we see that. So where's the iron? The answer is the iron was probably bound up in a compound along with the nickel. And when studying the different types of compounds that nickel can bind up with and that iron can bind up with, we make a discovery. And that discovery is that there's another very common cometary compound that could have been the culprit. And that is carbon monoxide, which is carbon and an oxygen atom, CO. Now, if we see that, and we'll get to your questions, by the way. I see some coming in. So if we see that, what we'll also see is that the nickel could have been bound up with 4 carbon monoxide molecules. And that's a compound called nickel carbonyl, okay? Carbon YL. So nickel carbonyl. Well, the iron, similarly, can be bound up with 5 carbon monoxide molecules, and that'd be iron pentacarbonyl, penta for 5. Well, the thing is, when nickel carbonyl is exposed to heat, it can vaporize and release the nickel atom to the environment around it. And that release takes place at 100 degrees Fahrenheit, for those in the Fahrenheit world. Iron pentacarbonyl doesn't vaporize until 200 degrees Fahrenheit, thereabouts. So as the comet got closer, the object, we'll call it, got closer to the sun, we noticed something. We noticed that the object started to show more iron. And that was actually something that we could possibly now explain. So the iron pentacarbonyl hadn't vaporized yet, and when it did, we started to see it. And now the thing we look for is the nickel to iron ratio, and which is Ni, nickel, over Fe, which is iron. So the Ni to Fe ratio started to get smaller as the nickel amount was balanced off by more iron on the bottom of the ratio. Okay, so the way that works is pretty cool. And so maybe that's why, and I only say maybe because we don't really know, you know. Now, let me get to some of your questions. I noticed a few of them. Mundus is here. How you doing? Linda Compton's here. And this is live, Linda. Absolutely. Melissa says she's in Atlanta. Fantastic. Yeah, let me know where you are when we're doing the chat. Dix Ram is saying Anunnaki. Well, I know that I've seen so many different ideas, and I love them all. Now, let's see. Blocker says people's lives will be changed. Well, they already are. This is an interstellar object that we have not seen, and it's acting very different from any other object that we've known in the solar system. So this is pretty cool. All right. Let's see now. I'm reading the chat here. VAB Bad says, able to view without using a telescope? Unfortunately, no. Sorry about that. Yeah. Our telescope is, you can see it right there. It's actually relatively good size. And we're imaging it, and it's taking us, if you look over here, 30 seconds right there. You can see the exposure over here. It's taking us 30 seconds to capture it like that with a very sensitive camera. So it is what's called magnitude 11. It's fainter. The higher the number, the more faint it is. When we first imaged it, when it was out past Jupiter, it was magnitude 17. That's really faint. And now it's gone to magnitude 11. And this is the brightest it's going to be. And then it's going to start to fade and fade and fade. It'll be a memory, and people will be talking about it for years and years. Mostly, though, see how it's extended? That's the comet nucleus, the photos being added to one another because we're stacking this. Okay, I'm going to clear it now and do this again. So people are going to talk about this for years and years because this is actually an incredible event, right? We're seeing something that's never been seen before. Hungama says, Alien Center. Yeah, I wish, actually. Right now, it doesn't seem to indicate that, but notice the tail is here, okay? And then you have this little projection here. Now, a question earlier that was asked was, and this is from Mundus Finite, why did it outgas towards the sun? Now think about this. One of the reasons could be that as it was actually facing the sun's radiation's hitting this comet right head on. So that part of the comet was heated up. Now, the surface of the comet is being eroded by the sun's light. Now, how is that happening? Well, the surface is made of carbon dioxide ice, water ice, okay, and so forth. But the key word there is ice, and ice melts with heat. All right. So, in the particular case of outer space, we don't see melting; we see sublimation. What's that? It goes right from ice to a vapor. It doesn't go to a liquid state first because the pressure doesn't exist; it's too low. So, we talk about the triple point of water and so forth, and that's where this comes in. And so if you look at this particular comet, as its sunward side, which is over here on the left here, all right, as that sunward side is facing the sun, what's happening is the comet is getting more heat on this relative face than the backside. So on this side, we're seeing more outgassing, that is, material being pushed out that's trapped. Think of the icy surface of this comet, and this is a major exaggeration, but think about the icy surface as being kind of a frothy ice, trapped gas, okay, inside carbon dioxide maybe, or other gases. You might have some hydrocarbons trapped in there, and as that ice is sublimating away, into a vapor, that gas trapped inside is now released and it pushes out with some force. And it doesn't have to push far or fast if it's pushing toward the sun, it'll end up out in front of the comet. All right, and that's not the only reason we see what's called an anti-tail. Here's the tail of the comet, but that's the only reason we see it. The anti-tail can also be the sweeping tail of the comet as the comet's curving in its path. The sweeping tail of the comet being seen, a more distant part of the tail being seen apparently in front of the comet, but that's a perspective effect, you know. So if the comet's going like this, curving around in the sky, and we're watching it from here, if we're looking at the comet here, we might see this distant tail that curves around here. We might see this part of the tail out in front of the comet. And that's something that's also called an anti-tail. That's very common. I took a number of pictures of Comet Tsusen Atlas a year or two ago, showing that very thing. And you see the anti-tail. It's very long, but it's just the dust tail seen in perspective. In this case, the anti-tail may be this outgassing that's occurring, and this outgassing from the frothy ice I've been telling you about, if you want to think of it that way, it would tend to propel that stuff forward. So any dust that it's taking with it is going to be out in front of the comet from our perspective, and it might be, heading toward the sun because that's the side facing the sun, and so it'll outgas off in the sun's direction. So this might be a very strange perspective effect that we're looking at here. Okay, so there's the tail, you can see it right there, and you got that little anti-tail there. All right, that's what we're talking about. Now I'm going to just save this one more time, save it exactly as seen. Okay, and now what I'm going to do is I'm going to give us a little more size here. Okay, so I'm going to clear it now, and this next image that comes in will serve as the next baseline for the next series. Okay, very good. That one's there. I'm going to save that one just like that right away. Every one of these images are available to you at skytourlive.org. All of this is available. So let's see. ST Win says hello. Hi there. How are you? And Darth Vader says zoom in so you can see the windows, etc. Okay. Yeah. It has no windows, unfortunately. And Melissa says, my dad raised me on Star Trek like a school class. I'm that kind of dad too, Melissa. Spock, we have got to get out of here. I saw William Shatner live somewhere, and when he came out of the stage door, I was probably 9 years old or whatever. He came barreling through the stage door to get back to New York, and he ran straight. When he flung the door open to get out of the stage, it smashed my father right in the head and knocked him down. And there's my father with a bloody forehead lying on the ground, and William Shatner picking him up. He's saying, I am so sorry. And it was so funny. And at the time it wasn't. But I'm thinking, Captain Kirk hit my father. Wow, this is so cool. Meanwhile, my father's on the ground. And William Shatner goes and picks him up and everything. Well, it's kind of funny. In later years, I didn't remind him of this story, but in later years, I worked on William Shatner's Unexplained show as a astronomer guest, and I asked them. I said, "Can I do my Shatner impression? Will he be offended?" And they said, "He has so many people that have done it. I wouldn't do it." And I went, "Okay." But I reminded him of the story with the stage door, and he was like, I can't believe I did that." Well, it's okay. No grudges, no lawsuits. We're okay. Everything's good. It was hilarious. Very, very funny. All right, so we got our comet. We have 5 images. It seems like 5 are good, so I'm going to keep doing 5 at a time. Remember what I told you, those that stuck around? I said, watch that star. Where was this comet? Moments earlier, it was right here, wasn't it? And now it's here. you are literally watching the universe change right before your eyes. That's pretty cool, isn't it? Yeah, it is. Neat. I'm going to make an adjustment while I've got the opportunity here. So I'm just going to go like this. I'm going to try and get a little bit more out of this. So give me a moment here to make an adjustment. There we go. We got that. And let's move that up. Oh, we did it. Nice. All right, got back to where I wanted to be. Nice. Okay. All right, so the comet now is about 170 million miles from the Earth. That's the closest it's going to get. Isn't that crazy? So Anthony says, so it's a comet. And you know what, Anthony? Yes, I believe it's a comet. Now, Avi Loeb from Harvard says there are some strange behaviors with it, and he's absolutely right. He says there's some anomalies with it, and he's absolutely right. And those of you that know me know that I've worked with him on a couple of shows in the past, and I know who he is. I've talked to his Galileo team to offer them a spot at one of our observatory locations. And I'm just going to save this and keep going. And so when he says things like, when he talks about it being potentially extraterrestrial, people get mad at him. They get mad and they say, oh, Avi Loeb, you're just sensationalizing. It's interesting, isn't it? Had he said it's only a comet from the beginning, people would have attacked him for that. But because he's being open-minded, he's being attacked for that. It's like the poor guy can't win. He's just speaking the truth. And the thing is, he's done a lot of scientific papers. He puts them out in rapid succession because there's a lot of science data that he's going through. And he was able to show that this object, even though my belief is it's a comet, this object shows, like I said, it shows this anti-tail of material that's being projected in front of the comet. As I said, I think it's because of the outgassing on the sunward side. It's showing a short tail. It was showing nickel atoms. It's actually doing something else that's very interesting. It's now showing what's called non-gravitational acceleration. Uh-oh, what's that mean? Well, actually, it's what we expect to see in comets. When they heat up and they outgas, all right, we see this fuzzy coma. This is the head of the comet, this fuzzy head of the comet. Well, that fuzzy head is actually that fuzzy head is actually something that's very interesting because it means that stuff is outgassing from the nucleus and going up into the area around the nucleus. That material that we're seeing right there is outgassed material, and because it's outgassing, it means that there is some type of outward force that this material being pushed off the nucleus of the comet is exerting on the comet nucleus. So what we should see is the comet deviating in its path. It should be doing this. It should be moving a little bit. But that's something this didn't do. And that's what makes this so exciting, because this comet should have deviated, but it didn't deviate. So because it didn't deviate, it meant that the comet either had to be forcibly holding itself in position, which a lot of people thought, or it's much more massive, and its mass was holding it more or less in its trajectory. And that's why Avi Loeb said that maybe this object was about 33 billion tons, which is a very big object, so when we look again, so the object then shows compounds we expect to see in a comet. All right, we have carbon compounds, we have water ice, we have carbon monoxide, we have cyanogen. You'll notice the comet looks a little green. Okay, well, it's starting to take on a more golden view. Yes, this is a live broadcast to is that Milan RS? Yep. And so this hue that we're looking at with this greenish tint, Well, that greenish tint is from carbon molecules bonded to each other, and cyanogen, carbon and a nitrogen bonded together in pairs, so CN-CN. Okay, and it's from any other potential carbon compounds. Now, and that green light, that's an emission. It's emitting light. Why is it emitting light? Because the sun's light is striking these compounds on the comet, and it's ionizing the atoms in these molecules. And when it ionizes them, okay, the electrons come back into the atom after they lose a little energy. But as they do, they give off light. And in carbon's case, that color is greenish. And so we see this green color around the comet that is specifically because of that effect. So that said, this is why we see that. Now the tail is the dust that is actually being left behind as the comet outgasses material, and it keeps moving, but the dust stays behind, right? There's no reason for it to follow the comet, you know? So that's pretty cool, you know? Milan from Sri Lanka, welcome. Very nice. You're probably the most distant viewer right now. You know, and Melissa says, I wish I found you months ago. Well, you found us now, Melissa. Make sure you subscribe. We do this a lot. There's over 540, almost 550 streams like this one out there of other astronomical objects. Right now, the Orion Nebula is so beautifully placed in the sky that I probably should view that too, but I'll do that in a little bit. I do want to capture the comet like this, and then build my image train so that I can show you the motion. I'll do that offline though. Now, this star is the one that I mentioned earlier to keep an eye on, all right? That guy, all right, the comet was right there just about 40 minutes ago, and now it's here. That's moving a lot faster than it did the other night when I looked at it, the other morning, I should say, because it was farther away from the Earth, okay? Now that it's closer, it's going to have the fastest relative motion to the background stars. And so that comet is literally speeding by us. Now, it is going faster. It's going about 144,000 miles per hour as opposed to 134, so about 10,000 miles per hour more. And that's because it got whipped around the sun. All right, we're gonna see that dash. This is a 30-second set of exposures, and we captured maybe 3 or 4 frames during this time, and it's already made a dash like this. That's something that we didn't see for several minutes in the past weeks when we looked at this. So that little guy right there is the extended coma of this thing. Let me clear and get the next shot. All right, so here comes the next one. All right, so here is the coma, that little extended coma right there. The nucleus is much smaller. And when people say, I want a nice clear shot of it, look, it's closest to Earth, why can't we see the detail? Because all of the stuff that's outgassing off the comet is getting in our way. And we can't see what we can't see, you know. Now, what we're doing is we're using telescopes like the NEOWISE, Near Earth Object Wide Infrared Survey Explorer, which is a telescope in space used to look for nearby Earth objects, like near Earth objects that could potentially pose a threat, and the James Webb Space Telescope. Those two have infrared capabilities that are pretty good. James Webb is far superior, but NEOWISE also does. And why infrared? Because we're trying to track how much carbon dioxide is on this comet. And carbon dioxide is not something in the visible part of the spectrum, but there's an infrared signature way outside the visible. See my hand's outside the view here? If this is our visible spectrum that we can see, red, orange, yellow, green, blue, indigo, and violet, okay, if this is the whole thing from red to blue, well, they're way out there. So James Webb sees way out here and way beyond, okay, and NEOWISE sees about here. So the visible part of the spectrum isn't helpful to look for carbon dioxide. But we're going to use NEOWISE, and we're going to be using the James Webb to do that, James Webb has already done a spectacular study of the carbon dioxide in this comet. Now, where's the carbon dioxide coming from? Well, we don't see it until we get reflections off the surface of the nucleus, or we see the emission coming out of this cloud. All right, and what we're seeing is spectra of carbon dioxide in that visible range, and it's going to be a line in the spectrum that shows up indicating carbon dioxide. All the molecules and elements they show in very, very specific locations in the spectrum. If that wasn't true, our science would be in the Stone Age. Because spectra are specifically assigned to specific slots in the like element spectra, like iron has lines in a certain spot. We can measure them. We know their exact position by number, and that number is something called nanometers, billionths of a meter. Okay, the frequency within our spectrum where you'd see the iron lines. Okay, and so if we can measure that for the comets, then we know what's in it. And so that's why the James Webb and the Neowise scope up there in space are very important. Now, why don't we do this on Earth? Well, we do. But the problem with infrared is that the atmosphere stops a lot of it. So to be in space means we would see an unfettered view of the infrared spectrum. And that's really critical. And that's what we're doing right now with the James Webb. Now that NASA is, back in business again because it was shut down, and that was maddening because that whole thing started to cause a problem. People started to think, oh no, NASA's not showing us imagery. That's not true. There was no one at the stations. There was no one there. The computer data was coming in, and it was just captured by the satellites, still capturing them. Hubble still worked. James Webb was still working, but there was no one to process and take down the imagery because they could not come to work. They were not allowed to come to work because of the government shutdown. So now that we're no longer, in that position, okay, we can now do the darn science again. And as a scientist, my goal, I'm an astronomer. That's what I do for a living. That's why these remote telescopes. I've got 2 in Arizona, 1 hopefully in Colorado, 1 out here in Connecticut where I live. This telescope's 2,600 miles from me. I'm running it from Connecticut. So now, hopefully with this funding for science again, we're going to be able to see more details about this. You may remember a few years ago a mission called Rosetta. Rosetta, like Rosetta Stone. And the Rosetta mission was aptly named because we were trying to get an understanding of comets. So we thought, why not go orbit a comet? I'm going to clear this and let us get a new one. So the Rosetta mission was to go orbit a comet, and it chose comet 67P, meaning periodic. Well, it had a real name. It was Churyumov-Gerasimenko, but do you want to say that all the time? No, 67P. That was the actual designation. So 67P was out there coming toward us, and it was we didn't know what the nucleus looked like until the Rosetta mission got there. Why? Because it looked like this. But once the Rosetta probe was able to get inside of this halo of debris, it was kind of immersed in it. It was able to orbit the comet slowly because the comet had very, very little gravity. So it didn't take a lot of effort to keep it in orbit. What it had to do was keep accelerating with the comet toward the sun as it continued to do an orbit. And Matt, that's quite a quite an achievement actually. And then it released a lander called Philae. That's Philae. And the Philae lander came down, and it had these anchors that it was supposed to fire into the ground and lock itself in so it could land. Trouble is, it landed on the comet. The anchors all fired. There were 3 of them. But unfortunately, either it hit rocks or the surface was a little too hard, and it acted like a gun, propelling it back off the surface. And it literally propelled itself like 15 kilometers or so above the surface again, and then the comet's gravity slowly brought it back down. I don't think it was 15 kilometers. I think it was a few kilometers. And then And then what happened? Well, then it hit the surface and bounced again. And I think it bounced 15 times before it finally came to rest later on, but it landed in a crevice. We did get a couple of views from that crevice, okay? And interestingly, that crevice is probably no longer there, because once it got around the sun, it's possible that much of that material has been ablated away, you know? So I think that the most important thing about seeing the comet here is to understand that they're constantly changing. And once we get in there, if we could get in there with a probe, we could see what this nucleus looked like. And you got to understand, this is killing me that we couldn't repurpose any of our probes and just send them out there, but we can't. You have to understand, Juno doesn't have Juno was one of the ones they suggested, since it's going to be hitting Jupiter soon, going toward Jupiter. They thought, well, maybe the Juno probe can look at it. I'm not sure what they're going to do, because Juno's life expectancy is coming to an end, so maybe they could make this a last hurrah and at least image the comet. Now, here's the interesting thing. This comet is going to approach Jupiter differently than we thought it would. Now, what does that mean? It means that the trajectory of the comet has been changing. Why? Because of all this stuff you see here. This outgassing is causing, look at that tail right there. The outgassing has been causing this comet to shift in its trajectory. All right? And so we're seeing jets of material pushing out. Okay? And they're causing the comet to now shift. We expect this. We see other comets doing this. And the anomaly with this was that we weren't seeing that initially. Well, now we are. Well, here's the thing. That shift has changed its orbit enough that it's now going to come very close to what's called the Hill radius for Jupiter. Now, what is that? All right. Think of a gravitational hill. As we get closer to Jupiter, Jupiter's gravity will eventually win out over the sun. And Jupiter's gravity will be able to have a significant influence on the path of the comet after that. So it's coming right close, almost exact, to the Hill radius of Jupiter. And that's yet another anomaly. Is that a coincidence? If so, it's a cosmic coincidence of megalithic proportions. So that's what makes this comet very interesting. It's doing things that continue to surprise us. Now, let me just get off of here so you can see it unfettered for a bit. I apologize for sticking my face in there. So what we're talking about then is this comet showing us many anomalies. Too much nickel, no apparent outgassing, a strange, it's the outgassing didn't move it, so it was much more massive than we thought. Its path through the solar system, hitting 3 major planets: Mars first, then the Sun, around the Sun, which isn't a planet, star, and then past Venus, and then on the way out up in March, it's going to pass Jupiter again, where it will be again very, very faint. This is the brightest we're going to see it. I'm going to clear this. We're going to almost get this next one now. So I clear this, and pow, here comes a new one. Okay. All right. Notice again, this was the star, and it was right here, not 45 minutes ago. So it's now here. That's an incredible amount of movement in that amount of time. So I'm going to save that. This is going to be a very interesting set of images. Okay. So again, when we talk about how comets operate, this thing is, I'll say this thing is doing stuff we expect to see from comets, but then it's doing stuff we've never ever seen done by comets, and that's really impressive. And that's why we like this so much. As an astronomer, I'm tickled pink to see the new data coming from this object. And by the way, please don't subscribe to the nonsense on the internet. Okay. The people saying it's a spacecraft, they're ignoring actual data. Now, I know Avi Loeb has suggested that it might be extraterrestrial in nature. And perhaps he thought at one point maybe it's a spacecraft that acquired material to make it look like it's acting like a comet, but it's not. It could be long defunct. That's actually still on the table. And that what's in the core of this comet could be something that was manufactured and maybe covered with ices based on its potential 7 billion year journey. Now think about it. They're saying this thing from its location it came from, it might be as old as 7 billion years old. Can you imagine that? 7 billion years old. Earth is 4.6 billion years old. This thing is almost double the age of our solar system. Not quite, obviously. So think about that. That's pretty cool. Pretty cool. And so, but that begs the question, if our solar system wasn't here, why is it coming through our solar system? Is it purposeful? And the answer is, I don't think so. We weren't even here when this thing started on that long trek. That was over when it was 5 billion years ago. Okay, our sun was only just forming. Okay, so we're talking about at 6 billion years of travel, or 7 billion years of travel. 4.6 billion years into its travel, Earth formed. The sun and the Earth and the planets formed. So it was already well on its way for billions of years. So clearly, it's not here because it's a targeted visit, in my view. Yeah, let's see. Let me read the chat here. What do we got? James Smith says Noah's Ark. We call it. Yeah, that's actually a good name for it. It might have a lot of building blocks of life on it that we know, and maybe some that we don't. Ooh. No, I'm very open-minded as an astronomer. I'm not supposed to be. I'm supposed to subscribe to dogma and just tell you it's only a comet. It's only a comet. But it's kind of hard when this thing is doing stuff that we don't see comets do. It looks like a comet. It walks like a comet. It talks like a comet. Quacks like a duck. All right. But the strangeness is telling us we need to rewrite our understanding of the universe when it comes to comets. Now, here's the analogy I've been using. You buy a cup of coffee at your favorite coffee place, right down the road from your house. That coffee tastes good. I don't drink coffee. I'm just imagining. And then you go several towns over and you buy a cup of coffee from the same chain, right? And it's like, oh, this coffee's not as good as the other chain, but it's still coffee. A different formulation, but still coffee. A different comet, okay, a different formulation in that comet, but still a comet is my point. So that's the side I'm airing onto right now, saying that it's different, but it's still a comet. And that's kind of important to understand. Now, you're hearing a lot of things about the comet saying, oh, this comet actually, this object is changing trajectory. And yeah, but understand that that's what comets do. That's what they're supposed to do. The fact that in the beginning, this was not changing its trajectory. It was following this ballistic path of like a rock. Yet it was outgassing. We saw stuff. So that meant, and this is what Avi Loeb's study showed, that meant that the object was showing a massive amount of outgassing. If you could see it all the way out when it was out at like the level of, at the distance of, say, Jupiter or Mars, okay, or Mars or Jupiter. However, seeing it out there, doing that, it wasn't changing its trajectory, which led to the formulation of its mass being 33 billion tons. Wow, that's a massive object. Okay, so that was a very odd thing. Coming through the solar system on the plane of the solar system, that was very odd. I want to make it clear. The solar system is not aligned like this to the galactic plane. Okay, here's the galactic plane. Here's the solar system plane. It's at a 62-degree angle. But if you look at it from the side, it came through like this. It came through, so it's crossing at the plane of our solar system from that perspective. And that's what we're talking about. It didn't go this way. Remember, the solar system's a circle. So it doesn't matter which way you cross a circle. As long as you pass through the center, you're coming in on the plane of the solar system that way. As long as you come in from the edge like that. And that's what we're seeing happen with this. All right, I'm going to save this, even though it's elongated. All right, and this is a good one because this is 13 frames stacked, okay, at 30 seconds per frame. And look at how far it's moved from the beginning to the end of that point. Look at that. So it was here, and now it's here. That's pretty impressive. So again, being closest to the Earth, it's actually moving the fastest it can be relative to the stars behind it, which are obviously light years distant. Okay, let's see in the chat. Yes, Linda Compton says, is this now December 19, 2025? Yes, it is. It is 7:03 where I am. For those of you in Orlando, it's the same price, same time. As Catherine Smith says, welcome, guys. If you haven't subscribed, please do. Okay, everything we do is free. You get a free astronomy. I'm an astronomer. It's what I went to school for. In other words, I didn't want to make any money. Astronomers don't get paid very well, right? And I decided to take my astronomy on the road, so to speak, kind of like a Bill Nye. And I worked toward making astronomy reachable by everybody, because it can get pretty dense. If you wanted, I could talk about the chemical properties of a comet. I could talk about the atomic transitions that give us the different colors we see in the comet. I could talk about all that stuff. But why would I do that? It wouldn't, for the people that don't understand that, it wouldn't involve you in the conversation. It would leave you in the dust. And I don't want to do that. So I want to have everybody involved in this conversation. So that's why I share things the way I do. I make it reachable for everybody, I hope, and that's for you to tell me, to make sure that I'm staying honest about it. Okay. And we have Kim Lewis says, I'm in Central Time, New Orleans area, still dark out. Yeah, it's actually just starting to get light here, but we have heavy rain outside. It's kind of interesting. It's heavy rain here, yet 2,600 miles away at the observatory, it's beautiful out. In fact, let me see if I can show you the all-sky cam view right now. All right, this is the all-sky cam I'm using there. It belongs to someone else. But you can see the clouds. We're looking here, though, okay, in the constellation of Leo out here. So we're not actually, we're not being subject to all this cloudiness, okay? If we were, none of what we're doing could happen. But this is the closest approach of, 3i Atlas, and I think it's very important that we stream this. All right. So that said, now I'm moving it, but I'm only moving the image. I'm not moving the camera. All right. So you can see the green color. Actually, when I move it, the green color kind of jumps out at you. And that green color that you see in this coma here, that's the carbon atom, the carbon elements, the element carbon bonded to other carbon elements, right? So you have carbon-carbon bonds, you have carbon-nitrogen bonds, and this is just the coolest thing. Oh, Sally Force says, love what you do. Oh, that's so nice. Thank you, Sally. Very nice of you. And then we have, Abhishek Kumar. I was at A&E Studios in New York last night filming, and there was a nice, the driver that brought me down was an Indian man, very, very nice guy. We had some good times, and his name was Bawinder. Very cool. I like that you're viewing us from India. I think that's a first, Mr. Kumar. Very first. And then we have Ragnar, who says, can't see it from Montebello, California, in Southern California. You need a telescope for it, by the way. So the telescope is the thing that's going to help you with that, unfortunately. Yeah. Catherine Smith says, Orlando, Florida. No snow, no ice, rare frost. Yeah. Yep. Yeah, and then Melissa says, Moving to Tampa in 2 weeks. I love Orlando. All right, cool. Hey, it brings all kinds of people here today. This is nice. And then Just Pixie says, midday in the UK. Yep, that's right. You're 4 hours or 5 hours ahead of us, aren't you? Yeah. Yep. And Daisy and Zoe Amethyst said the rain woke me up. Yeah, me too. It was raining really, really hard here in Connecticut. Yeah, neato. And then we have Trent. Trent is on cool. All right, cool. He says, "Let's go evolution, human origins." Well, what's funny is when we look at a comet like this, we're actually potentially seeing our human origins in their raw form. It's very possible that a comet like that one struck our planet. We know it's happened. We've had three impacts that we really know of here. All right, we had the Chicxulub impactor that eliminated the dinosaurs, and there was another one that struck Greenland, northern Greenland, that might have been part of the same impact, potentially. There's a big crater in the north side of Greenland underneath all the glacier. Then we had the Younger Dryas event where civilizations were literally exterminated by some kind of an impact because there's sand from the ground fused into glass on ruins, and that's something that you just don't have happen with war, bombs, fire. No. You need many tens of thousands of degrees to cause that to happen that fast. Maybe thousands of degrees. Much hotter than any metallurgy could make quickly. And this was all very quick. And then after that, of course, in the early 1900s, we had the Tunguska event in Siberia, where what looks like a small one of those, a small comet, entered our atmosphere at high speed and, of course, hit the atmospheric wall where it could no longer stay together anymore because of all the pressure and force on it, and exploded. And all that energy of motion is translated very quickly to some other type of energy. And in the case of something impacting whether the moon, impacting the ground on the moon, or impacting our atmosphere, that energy of motion is transferred to the energy of heat. Now, you may also remember, some of you, that it was only 2019, I say only, that was a bunch of years ago, but during a lunar eclipse on January 20th of 2019, we are one of 5 groups on the entire planet that caught a meteor hit the moon at the height of the lunar eclipse. The moon was red, and we saw this bright white flash poof, down in the corner. It went like this. It was this fast. Poof, and then it was gone. You were seeing the instantaneous heating and vaporization of a small meteor that turned out to be about 18 inches across or so, hitting the moon. And we captured that. It's in our, if you go look through our streams, we've got over 545 of them or so. You'll see it. And you can actually watch it and go to that point in time. It was around 11:30 in the evening or so, and we saw it. Look at the comments, how extended this got with 16 30-second frames. So this is 8 minutes. In 8 minutes, it's gone from here to here, right? This end to this end. It looks like a dash. Now, this serves a purpose. A photo was shown from Mars of I forget which satellite around Mars took the picture, or it might have been the Perseverance rover. I can't remember, but it took a picture in the sky, and it took a picture of the comet as it was passing Mars, and it was a dash. And this led people to say, "Oh no, it's a cylinder," and they started making all kinds of things, like the Doomsday weapon from Star Trek. Okay, talk about your dad making Star Trek your thing, right? Okay, as one of you said. Well, that sparked an entire non-event of, or I should say, hoax, that this was the Doomsday weapon from Star Trek, and they even showed pictures of it stretched and made to look more real. Hilarious. Well, anyway, So you see this now. And what we'll do is, if we clear this, all right, you'll see that when the comet comes in, it's actually a round ball. But because it's moving and we're taking a time exposure like that satellite did, or that rover did, you don't get a dashed line. We see a dash. That's the result of layering these images, taking a long exposure. And what we did was effectively an 8-minute exposure, right? But that's what it looks like right there, okay? That's what it looks like, you know? Now, don't forget, it started right here, and now it's here. I'm going to save it right here because that's going to become one of our next paths. Yeah. Darius, welcome. Good day, welcome. We're doing fine, thank you. Are you in Australia by any chance? We have several Australian viewers. Yeah. Yeah, I'm going to read some stuff here. Seth said, are people expecting something extraordinary to happen, or just observation like any other comet? Truthfully, Seth, I think people are hoping things are going to happen. But as you can see, it is a comet. I hate to say that. I mean, it appears, it acts like a comet. It looks like a comet. It's doing comet things. Okay? But the anomalies are not something to be trifled with and dismissed. There are anomalies. Okay? Like I mentioned earlier, one of the anomalies is that the fact that it's now outgassing more, this anti-tail, which you can see kind of right here, okay? This little anti-tail that it's making, all right? This anti-tail right there, and then the main tail right here, that's gas that's being ejected forward to the sun side. Now the sun is down there, okay? So it's lighting this side of the comet right here. And so because it's lighting this side of the comet, this side gets hotter and pumps off more gas and other things toward the sun. So the sunward side is actually becoming more active. And so that's changing its trajectory. Like little rockets pumping gas out constantly over time is going to make a big difference. And it is. So by the time it gets in the region of Jupiter, what's going to happen is it's going to reach a very interesting place in Jupiter called the Hill Radius. Now, the Hill Radius is a point where Jupiter's gravity takes over from the sun and is more significant than the sun. Even the small moon, as soon as we reach a certain point, okay, the moon's gravity takes over from the Earth. All right. Yes, the Earth is still has an influence, but it's not as great. And so that's what's going to happen here. We're going to actually watch as the comet reaches Jupiter. It may be more able to change its trajectory because it may be more affected by Jupiter's gravity than the sun's. And so the result will be a blend. That doesn't say anything bad for us. It's leaving the solar system. It's not coming back. What you're seeing here, you'll never ever see again. This is a once in a lifetime right there. Once in a lifetime. All right. You'll notice I'm not moving the comet into the center. That's because I'm creating the ability to create a path that I can animate and show you where the stars don't move, but you see the comet moving. All right. Very interesting. Yeah, and let's see. I'm now getting an error. Oh yeah, we must be behind clouds because I'm getting no guiding taking place here. That's okay. Alright, I'm going to clear this anyway and see what we get. We're looking at a sky that's cloudy in certain areas, so you can see the clouds moving in. Let's see if it's getting that bad. There is a cloud bank. Yeah, that's moving toward us. And right now, this is what we're looking through right now. We're trying to look through. So I'm getting an alarm saying that the telescope is unable to guide. So we'll do that. Let's see if we can even see the comet anymore. Yeah, the same exposure shows us only a small little blip. Right, and this reddish color in here is due to the cloud. And remember, we started at this star, so we went pretty far. We got pretty far here. We can still see the tail. I'm going to teach you something too. When you look at the comet directly, you may not see stuff, but if you look over here, you might see the tail right here. Okay, that's because the sensors on the side of your eye, called rods, are more sensitive to light than the cones, which are the color receptors in the center of your eye. So the faint patterns can be picked up easier by looking over here. So if you look at this this little fuzzy star here, you can see the tail of the comet right here, even though it's behind clouds. See that? That, again, that's called averted vision. Let's see. Okay, let me look at the chat here. Wake up early, 6 a.m. Thanks for the information. Of course, of course. And we have Rugrat watching from Canada. Fantastic. Thank you. We're doing our best with the sky as it is. You can see we're not guiding, so the stars are elongated. I'm going to clear this and see what the next image looks like. The cloud bank is going to dissipate. Yeah, see, the comet's barely visible now. And we were seeing it before when there were no clouds. And the cloud bank may nix the rest of the early morning for us. But if we look here, okay, if I refresh this, you'll see that this is more toward the center. Watch. See? So this is coming this way. So this is now that down there. That is clear. That's the clear spot behind it. So we'd have to wait for all this to come through. But as we do that, we're going to start seeing sunrise. And right now you can kind of see at 5:20 a.m. out in the desert there, you can start to see a little bit of the glow of sunrise. So it's actually not that bad that we got this far and maybe can't see the comet anymore. We're going to have a little bit of a break here, so let's see if we can capture this at least one more time. Let's try. Let me try with this. Let me see if we can get some kind of image. Yeah, no guiding yet, so we're probably not gonna. It's looking through clouds that are too thick at the moment, but let's see. Yeah, this was fun though. Yeah, there's the comet right there. Well, we'll wait it out a little bit. All right. Darius Eversol says, basically the orbit's eccentricity is so high, I guess, that's what is called escape velocity, meaning it's not an orbit, just passing through. That's right. The eccentricity of this comet is over 6. Now, let me explain what that means. If you have an orbit, or like the Earth does around the sun, okay, that orbit has an eccentricity. That eccentricity is close to 0. And when the eccentricity is near 1, but not 1, less than 1, that's progressively more elliptical orbits. So Pluto has a higher eccentricity than the Earth's orbit. It's a little bit more elliptical, okay? Most of the solar system comets have higher eccentricities, but less than 1. If you reach an eccentricity of 1, then you're on this parabolic path where you're not bound by the gravity of the solar system or the star system you're coming from. And if you're greater than 1, you stand a chance to have a hyperbolic path where you trace, if you remember geometry, and maybe you don't, there's a shape called a hyperbola. And the cometary path is hyperbolic. It's on this hyperbola path. So it's coming through at high speed, and it's not going to slow down. The sun pulled it in and actually made it go faster. and on its way out, it's still moving 144,000 miles an hour. Now, the other thing that I'll mention here, while we're waiting for potential clearing of this little area, is that the comet's speed of 144,000 miles an hour, being so fast, it's kind of spooked the world. And so what they've done is they've done this, and you've heard this probably. They're using this event, this object right here, this comet, is being used as what's called a live fire exercise. And what that means is that they're saying, okay, we've had 3 of these things since 2017 come through our solar system. And they're moving very, very fast. So we need to have a response plan, a way to combat them, and maybe nudge them away if they're going to actually come toward the Earth. There's none that are currently. There's none that we know of that are coming close to the Earth right now. And no asteroids either that are going to come close to the Earth. I think we're safe for over 100 years right now. So the point is, when we look at the comet world, okay, especially the extraterrestrial kind, these come so fast that it's possible that these comets might actually cause a serious problem, and so we have to have a response plan. And that response plan is going to be that we actually have a way to divert it. And we had a mission called DART, Dual Asteroid Rendezvous, where Didymos and Dimorphos were 2 asteroids that kind of orbit each other. And we hit the smaller of the 2 with a kinetic impactor, which is basically a giant weight. And we successfully changed the orbit of the smaller around the larger. And that was cool. Because I think Didymos was the bigger one. We changed the orbit of Dimorphos, and that showed we can divert solar system objects if we have the time. Well, we don't know if we have the time right now, okay? That's the other problem. We're not sure if we have the time, but we're hoping we have the time. Now, let me just bring that up again. Thank you. All right, so as you can see, the red sky, again, the pre-dawn light showing up much brighter. Let's see if it's going to show here as a more obvious. All right, and we're getting, again, this is the end of it here, but it'll be light before this gets here. Okay. All right, but let's see what we can get. All right, so anyway, so they're using this as a live fire exercise, and what that means is that they're trying to get together a communication network to make sure that we have a way to communicate and respond to what could be a disastrous event for our planet. And at the moment, the live fire exercise is simply trying to. Okay, I gotta change this here a little bit. No, I don't. The live fire exercise is meant to showcase our ability to communicate and come up with a plan, like DART. But the trouble is, we have to do it when it's far away, because we can't really do this when it's nearby, because then the impact has to be even greater, much more of an extensive strike to move something. And if it's 33 billion tons, like was estimated by Avi Loeb, how are you going to move that? You got to move it with a very large one, a large hit. Now, some will say, well, let's just nuke it. Here's what happens when you nuke something that's like that. A 33 billion ton object is not that big compared to a nuclear weapon. So what happened is a single 33 billion ton object could be broken apart by an impact of a nuclear weapon into 6 billion ton objects, which would be 5 reigns of death on our planet. Oh, there's a Starlink satellite. Okay. So using a nuke is just not that good of an idea, especially when you don't know the composition of the object. A nuke won't melt it. The sun didn't melt it. Okay, so a nuclear weapon won't melt it either. You know, so a kinetic impact might do something. Another way to do it is to land a little thruster on the comet and fire a rocket and let it keep firing. And as it keeps firing, it's going to propel it a little bit one way or the other. So that is something that we would also consider. And we do need to have a response plan. So the live fire exercise is just to build a response network and maybe use something like DART. The idea, of course, being that we need to catch these things way sooner in the sky, all right, in order to be able to respond to them. You know, so let's be clear that that could happen. There's our comet again, another Starlink satellite. Yeah. Yeah. Darius says, yeah, a small effect very early on can change the course of something much more when done from greater distance. Absolutely. Yes. A 500 meter change when it's 3 astronomical units away is going to do a lot more to the trajectory than a 5 meter change when it's like, you know, the distance of the moon. You know, it won't make any bit of difference. It'll just hit in a different spot on the Earth. So yeah. All right, let's see now. I'm missing some of the text here. All right, let's see. Michelle's saying some interesting things. Everybody is. Ghost Ridge, hey man, how you doing? And Jess says stormy here. Yep. Yeah. And Melissa says we're in a simulation, I think. You know, I'll say this. Before the Matrix movie series, no one even considered this simulation idea. This was just an offshoot potentially of the Matrix movies, maybe. I don't know. And then we have Albert Moyer, I think, Moira, says, of course he's responding to somebody else. Yeah. Let me read some more. By the way, if any of you aren't subscribed, subscribe, man. We do special events. We do clear night streams. And boy, oh boy, we show nebulae, galaxies. We see individual stars in other galaxies. That's how good we are with this stuff. All right? Not to pat myself in the back, but I've done this, you know, as a professional astronomer for enough years that I want to just share it with you guys, and I'm really, really happy at what we produce for results. Not now. I mean, earlier tonight we had a really, really good set of results. You can still see the tail and the anti-tail a little bit, you know. But let me I'll clear this and see if the next one comes in. I'm not doing any guiding at the moment because when I try to get the guide star, it can't see a guide star because of the clouds, and I can't deny that's a problem. I mean, there's a star there. There it is. Hey, look, it's back. We got a little break in the clouds. Good. So we'll just guide on that little bright star peeking through the clouds for the moment. Okay. And now, this is good because it shows how far we are from that star that we looked at earlier. And in just the hour or so we've been on, it's gone from here to here. And that's the fastest it's going to move through our solar system as far as we can see it. All right. Now I'm going to, again, the red is the pre-dawn light out there. I'm going to try and do some processing to help it look a little better, and it's still not guiding perfectly, so the stars are are not absolutely perfect. So we'll clear this. We got another one coming up. Let's see if this one's going to be better. Not really. We'll let it build. We'll see what we get. mystical rock hound dog fossil. That's a great name. Or mystical rock hounding fossils. That's a cool name. I'm a fossil collector. I just got a couple of dinosaur eggs from someone that had collected them and didn't want them anymore. They're beautiful. I have insect amber, which is really cool. Under a microscope, you can actually see the details of these insects that lived tens of thousands of years ago, even approaching 1 million years ago, hundreds of thousands. Ricardo Jorge, welcome. The telescope is in Western America, Western United States, in Arizona. We have 2 of them out in the desert out there, one here in Benson, which is where this one is, and one in the Sonoran Desert west of Phoenix. That's a wide field system out there. This is a narrow field system, the only one that we would use to look at the comet. That's pretty good. I can save this shot. I'm in Connecticut, all the way on the East Coast, so I go back and forth to work on these buildings as necessary. I have people out there that are part of a nonprofit organization. I take no money for what I do. I take no money. I put it all into equipment to bring you guys a better experience. Just have to. But mystical rock hounding fossil says Atlas seems to be nothing interesting, just a distraction. Oh, far from it, my friend. This comet is actually showing us things that are going to force us to rewrite what we understand about the universe. Okay? Now, I gave this example earlier. You get a cup of coffee from your favorite place, and you get a cup of coffee from a place a state away. And what do you discover? You discover that it doesn't taste anything like your favorite cup of coffee, but it's still coffee. So you analyze the ingredients of the coffee from a distant state, and you compare them to the coffee in your local state, and you see the differences. Well, that's what this comet is helping us do. We're seeing the differences in what this is versus the comets that we have in our solar system. And that's the purpose of why this is so special. It's showing anomalous behavior we can't explain yet. It's showing a variety of changes that are troubling to explain. In other words, they challenge our astronomical understanding. And the way to put it in terms of the analogy is, we haven't figured out what that out-of-state cup of coffee is made of yet. Why it's acting the way it is. Why is it color what it is? Some of these things make sense, and they're part of our understanding, and some of them just aren't. And so that's what we're looking at here, is trying to figure out what parts of this don't make sense and what parts do. I'm going to clear this and go for another one, see what we get. Lavalier done. That's funny. Melissa says, I wish I found him 6 months ago. I don't know who him is. There we go. It's still back. I'll take a quick snap of that. That'll serve as a data point to show its motion. Save exactly as seen. We're getting the capability soon to actually examine the comet and figure out for ourselves what it's made of. That's called a spectrograph or a spectroscopy. And we're going to be doing that, not with this telescope, but another one that'll be in that building. Thanks to Asterion Foundation, which is down the lower right there, okay, Asterion has given us a small grant to actually get that spectrograph system for our telescope right there. Asterion, phenomenal. And you may have heard of Lowell Observatory. Lowell Observatory is part of the Asterion family, so they're going to help us, or they have been helping us to allow us to further our astronomical capabilities. Let's see here. Tuber 26 says, waste of time. Okay, see ya. You got your little dig in, and now you can take off. We don't want you here. All right, let's see here. And wake up early. He's from New Jersey, or she is. Nice to see you. Eric says fossils are really interesting. And yeah, I mean, if you look at the fossil record, look at me doing this. Okay, the fossil record is interesting because it shows us what happened here on our Earth. It gives us a view of the early life on the Earth and how it lived, where it lived, how it interacted with the environment. And we saw a lot we find a lot in the fossil record that is literally writes our history for us. That's very important, Melissa says it rewrites everything we believe about comets. There are like 17 anomalies. That's correct. And you said it correctly, Melissa. Congratulations. It rewrites everything we believe about comets. And that's because it's an interstellar comet. This is only the second comet we've ever seen from another star system. Think about that. The chemistry, the ingredients in this comet came from another star system. And if this comet has ingredients of life in it, well, that means that other comets from distant solar systems, different star systems, could have delivered some of the life-bearing building blocks to our planet. And I believe that is true. I believe that to be true. Let's go check out our morning light, see how bad it is. It's looking brighter out there. Yeah, well, we're getting a little area here. You can see the red showing up here a little bit. So it's starting to show dawn light. You can see some light down here penetrating behind this hill. So we're getting some dawn light out there, but we're still actually able to image some more. Nico Spoon, how you doing? This is the second interstellar comet, Nico. The first one was Oumuamua. We call that 1I, Oumuamua. 1I meaning the first interstellar object we saw. It wasn't a comet, it was more like a rock. 2I was Borisov, second interstellar object. That was a comet. And 3I, Atlas, is the third object and the second comet we've seen. So, and Home Pimpson says you're not even showing stuff. Well, is that true? When did you join? Did you miss the earlier showcases where we actually had no clouds? Yeah. If you don't like it, you can leave. We don't care. I don't care. I just, like I said, we do what we can with the weather we have. And we had a very clear sky for a long, long time, and now we're getting clouds. They weren't there before. Robert Pace says, I live in Reno. Thank you. I'm watching live from Reno. Fantastic. And put a lid on it. Says, I believe it's time to launch world leaders into space. You're absolutely right. Wouldn't that be cool? Send them all into space. Every one of them. And then let them fight it out up there, That's really funny. Yep. And Eric777, a very good point. It happens every time a comet appears where people will say it's the end of the world. And guess what? You're absolutely right, Eric. It never has been. Ever. And is it possible that that could happen someday? Well, maybe. But it's not what we're seeing now. You know, I'm clearing this at the end of this exposure so we can bring in the next one. Oh, there we go. That's a little better. You can see the tail. All right. Now, again, as a reminder to those latecomers who said I'm not showing anything, here is where it was when we started. It was right below this star. And just an hour later, it's gone here. And we all have watched it move. It's really cool. You know? Okay, Darius says, what did you think about what I said? Of course, a rocket that can move something like this Rhea Atlas could take a very big rocket to move it appreciably. Yes, of course. And that's why the rocket intensity, the force imparted by the rocket will skyrocket, no pun intended, the closer the object gets here before we can reach it. So it'll rapidly outstrip our ability to stop it. So what we'll do is put up a set of instruments that watch the cosmos very, very deeply out there, which is what this live fire exercise is all about with the world leaders and with world science organizations, and establish a network that will be able to allow us to see objects when they're really, really far away, giving us time to respond to them. So keep in mind, it took us a long time to get out to Jupiter, okay? And it wasn't measured in months, it was measured in years. So if we catch something out there moving as fast as this has been moving, it only took it a few months to go from Jupiter's orbit location to being closest to Earth that it's ever been. All right. So how would we stop something like that? We need something a little more powerful because we're not going to see it and be able to launch in time to rendezvous with it and move it if we don't have some good plan in place. And right now, we don't have that plan. We have ideas, and that's all we've got. But we don't have plans. We're going to try. We're going to try and figure something out, which is the important thing. And this live fire exercise is going to help do it, I think. Okay, that one we did. Save this exactly as seen. There we go. Yeah, all right. I'm hanging out until it goes away, until we can't see it anymore. Let me look at what's going on here. Beast Mode has joined us. Beast Mode says, 3i Atlas might be an alien ship, but I don't think that it would visit Earth and do some stuff like many people think. Yeah, not necessarily. Yeah, right. I mean, if it was an alien craft, it could approach us and do something that we wouldn't expect, and that's not at all unheard of. You're right. It could be all that, you know. Put a lid on it. Says Atlas has already moved planet Earth at 0.002%. I don't know where you heard that. We don't have a good mass yet on Atlas. I mean, we thought 33 billion tons before it went around the sun. So, and that was Avi Loeb saying that at Harvard. But so right now, I am not sure if we could say it moved the Earth at all. But maybe. Okay, I'm bringing this up now, and I'm gonna, let's see if we can pull out any more detail in here. Okay, so the coma is elongated a little because we're exposing this for 5 minutes even right here. This is a 5 minute. In 5 minutes, it's gone from here to here in just 5 minutes. So you can see it's moving the fastest it's going to move against the stars because it's closest to the Earth. So Deadpool asks, so what is Atlas, 3i Atlas now? UFO, aliens, or just comet? I, as an astronomer, I'm open-minded. Unlike a lot of astronomers, I'm actually very open-minded. Avi Loeb at Harvard's very open-minded too. I tend to think that this is just a comet. He thinks there's still some possibility that it could be a strange object of extraterrestrial origin. Although he doesn't say that directly. And I hold out hope that it is, but it's doing comet things. Yeah. Yeah, okay. Put a lid on it. Next up is the Tilt-A-Whirl. Yeah, the Tilt-A-Whirl. I enjoyed that as a kid, but I don't know. I reached a certain age, and my next run on the Tilt-A-Whirl was almost ended me because it made me so sick. All right, we're going to clear this now and get this next image and see what we've got. Let's take a look at the night sky here and see how bad the clouds are. Okay, so we're getting a clear spot here. And now you see the red is, now dawn is coming in, but we're going to keep going until we can't. So we're looking, oh, there we go. That's pretty. I'm going to save that right away. All right. Nice. All right. We're going to take our mid-level here and move it down a little. Kind of reduce the noise. You can see the tail there. The anti-tail is right here. You can kind of see it. And that the sun is down here in this image, down there. All right, now let's do this. Let's move this back off our peak. This is our black level. We don't want to lose any data. If we go here, we'll start losing data. See, look. All right, so we come back before that peak. And this gives us our most data. And if you notice, it sort of takes on a yellowish greenish hue. I noticed actually early on that this is looking more yellow in some ways. Here you can see a green halo. That's the carbon molecules there and cyanogen molecules that are causing that comet to glow green. Okay. Pam says nothing seems to be happening. Well, this is going to be disappointing for some people, Pam, and I'll tell you why. Because you've been seeing on the internet that the aliens are coming. They're gonna, when it gets closest to the Earth, they're gonna land. They're gonna do this, and you're seeing what social media is doing to the science world. You're watching social media basically turn the science world into a joke, and they're taking an event that has a scientific origin and they're trying to make it into something it's not. This comet is a strange comet. It's unlike comets we've ever seen before. So we're looking at this with a critical eye to try and understand why it came in on the path it did, why it was showing nickel the way it did early with iron later, why it has an anti-tail, which you can see right here. All right. And it means it's outgassing. This is the sunward side. The sun is down here. So this front end of the comet is getting hotter than the back end of the comet. So the sunward side is outgassing, and I'm thinking it's pushing material out ahead of the comet. And so thus we're seeing this. Now, that means that it has a composition unlike any other comet we've seen. And it does. It's an interstellar comet. It came from another star. Our pool of material from which our comets were made differs greatly from what made this comet. So where this one comes from, we find is from a different nebula that started the star that this came from. So very interesting stuff. Oh. Mystic Rock Hounding Fossil says, what will be next? A Miami Mall? And another thing from space? I think you're talking about, when you say Miami Mall, I think you're talking about the supposed aliens that were down in Miami Mall. Yeah, who knows? I am the chief photo and video analyst for the largest UFO organization on the planet. Okay, so know all about some of these cases, which are humorous and interesting, to say the least. I take all of them seriously until we can figure out what's going on, and if we can't, then they stay serious, and I think that's fine. For those just joining, this comet started over here. When I was first taking pictures, it was right below this star, and now it's over here, and that's just in like an hour and 20 minutes or so, however long I've been streaming. Pretty cool. I'm reading some of the chat. And we're getting Sardar Singh says, when will 3i cross? What is the Atlas time? Not sure what that means. This is 3i Atlas right here, obviously. So this is the comet we're looking at right there. It started here earlier this morning, and in the time we've all been watching, it's moved to here. That's why it's elongated. In just 5 minutes time, you see an elongated nucleus here. I'm going to save that, and then I'll save it exactly as seen, and then I'm going to clear this, and we will have in just a few seconds, because I'm doing a 30-second exposure, we'll see the next exposure of it. Eric is relaying a UFO sighting he had. That's interesting, Eric. Disc Jockey Rooster says, thanks for your excellent commentary. That's a good play on words. I like it. Guessed a bit on physical size of this. Yeah, I know. That's a very good question. Look, we got our sky back for a bit. This comet, in terms of size, we know its mass, but it's hard to say what the nucleus looks like. It could be a big, lightweight thing that amounts to 33 billion tons, or a small, compact, heavy thing that whose density amounts to 33 billion tons. So the size is unknown. I would think that it's probably a little bigger than most comet nuclei we've seen. It's been very active, doing very interesting things, and maybe this is one of the biggest comets the universe can offer us. This guy right here, not bad. So yeah, I'm grabbing him right here. I'm gonna take him and move him. Wouldn't that be funny if it moved? I'd quit my job, I can tell you that. Anyway, and Darius says, I would agree we should keep an eye on everything that's coming towards the Earth, and put rockets on anything that could hit the Earth and direct it to miss the Earth. That's one of the many plans. The other one is to actually detonate a nuclear explosion out in front of it, where it doesn't disintegrate it, but the energy pulse and the thermal pulse move it. That's another possibility. I mean, that might be the only good use of nuclear weapons, to be honest with you, is to save your planet. But we can't blast it to pieces, because then we're going to have millions of smaller pieces that could penetrate the atmosphere and cause much more damage. Give you an example. Let's suppose this thing is, I'll say 10 miles across. No, 30 miles across. We send a nuke out and we blast it. And yes, it goes into millions of fragments and the world rejoices. Okay, our world is saved. But now all those millions of fragments, they're probably in the amount of trillions of fragments, some being pretty large, enter our atmosphere. As they enter our atmosphere, what do? The friction heats them up and then they burn up. What does that burning process do? It heats that part of the atmosphere. And if you've got millions of these little particles entering your atmosphere and burning up at the same time, key point, then the Earth's temperature can rise and could rise higher than life could withstand. So you see, either way, it's just not a pretty sight if we blow one of these things up. So you stay intact. We'll leave you alone. Just go along. Move along now. Move along. It's right at the edge of my field because I'm not moving our stars. Okay, I'm not moving my telescope, our telescope. I'm leaving it there so we can actually have this motion when I build the motion path and show you this at another point later on today. Billionaires King said, is an alien spacecraft? Okay, is it an alien spacecraft? The consensus is no, it's not an alien spacecraft. The consensus is that it's probably a comet. My likelihood on the 0 to 10 scale, with 10 being fully alien, right now I'm at like 0.5. I think that it's probably a very, very major reach to say that it's actually an alien spacecraft. But you know what? Stranger things have happened, haven't they? And I certainly am not going to get in the way of it if it turns out to be true, but I don't know that it has. If you're just joining us and you know what we do, or if you don't know what we do, here's what we do. We show you the night sky and astronomy. I'm an astronomer. That's what I got my degree in. And this is Sky Tour live stream, and we will stream on most clear nights. The telescope is located 2,600 miles away from me out in Arizona. This is one of two that we have out there. This one is 220 miles from the other one. So if it's clear at one side, it may not be clear at another, that kind of thing. So I never get any sleep. So join us and subscribe. It's all free. You can support us if you like. If you go to skytourlive.org, you can donate to us if you feel like it. You can give us a super chat. You can just watch and enjoy, and I welcome you. I take no money for what I do with this. None of us do in our nonprofit. This is all about educating you in the science of astronomy, because I think it's important to bring all of you into the discussion so you can see what's going on. That's critical to me. All right. So you can also, if you want, with Christmas coming up, it's kind of coming up quickly. We have, I'm going to just give us a little more processing here to show that tail. Okay. With Christmas coming up, we have t-shirts that are really cool. On the front is our logo, skytourlive.org. Really, really sharp logo. And then on the back side, you see all the planets, including Pluto. It is a planet in my view. And it says in the center of it, I need my space. Very colorful shirt, very nice. Makes great gift if you want it. And if you want to see what else we do, you can go to our Etsy store up there. Our Etsy store is called Sky Tour Shop. You can see it right up here. Okay, there it is. Okay, Sky Tour Shop. we take some of the many images we've taken over time, and we've taken hundreds and hundreds and hundreds and hundreds of images, and we can we put them on mugs and glasses and water bottles and mouse pads, you name it, boxer shorts and sneakers. I mean, we got it all. T-shirts, and you can buy one, blankets, and you know, get that for a gift for someone. And it all supports us. You know, it just supports what we do, and all the money we make goes back into furthering what we do. We have Starlink out here. That is the Starlink antenna. You can see. You can't see it, not right here. Let me just show you that. Let me bring this down a little bit, and bring this down a little bit. There we go. Yeah, you can see it right now. This is the Starlink antenna. Okay, that's there. That's an infrared light, and our current camera, this one mounted over the roof. Okay, these are pan tilts, so we can actually move them around. I'll show you in a sec. While we're building our comet image here. Okay, so if we turn to the right, you'll see we're on a mountain with a bunch of other astronomers. Okay, this is all our building that's illuminated here, but in the distance there, you see another telescope. There it is, and that's this telescope operated by the guy next to us. You also see some of the clouds in the sky, and he's looking at something else out there. And he's missing the boat. He should be looking at 3i Atlas. All right, and so there we go. Now the sky right now, let me look up here in the sky. We have some stars. Not bad, not bad. Okay, but we can see a silhouette of the mountain in the distance there, right there, which indicates that it's actually getting brighter out there. Because normally we can't see that at all. It's too dark. Okay. So, let's save this like this. Again, we're building a path from here all the way to here. It's going to be a nice smooth path. I think you'll like it. I want to say hi to Water Rat. That's Matt. He's joining us, checking us out. SKJ Shy. The heat basically does in fact cause the comet to sublimate its ices to vapor. Yeah. All right, there's the comet again. I'm going to pull this up to the peak, the black level, darken it up, slide this down a little bit to give us a little more noise-free view. Okay, and you can see the coma around the comet. It'll get harder and harder to see now as the sun starts coming up. Weewa said, where in the screen had moving? Okay, it was right about here when we first started, and over a period of the time we've been streaming, it's moved all the way to here. It's moving at the fastest speed relative to the background stars that we noticed right now, okay? Because it's closest to the Earth right now. Yes, this is live. You're seeing this right this very second. This is a live broadcast. This is not fake. It's live, and we're seeing 3i Atlas live right now. Yeah. This is the kind of stuff we do. So if you want to see stuff what we do, just subscribe and like us, man. Help that algorithm so that people like Michelle will know we're out there. Because she didn't know we were here. And Rockstar's with us. How you doing, brother? Rock's one of our regulars, as you can tell. Kim Lewis says, absolutely enjoyed the live stream. I've subscribed and will share it with my family. Thanks, bunch. We used to Skywatch as a family. Now all the kids live in different locations. Yeah. And well, guess what? When we do this, we actually have people that live across the country from each other who used to live near each other, and they all come into the stream and catch up and talk and check out the beautiful views. It's so cool. Let's see what this does for us. Yeah, that's more the proper color. This was a golden color earlier, which was really neat. I'm going to take this, move it over to the peak to give us the darkest view we can get. There we go. That's pretty cool. Now I'm doing this at a very high, and I'm still not showing it right. I'm doing this at a very, very high sensitivity on our sensor, and that sensitivity is and can be problematic. I'm gonna just move this down so you can see the rest of the screen there. There it is. So we're at 300 sensitivity, and that allows us to see more of the tail. All right. Jay McCoy Magic. Hey there. Has NASA released the pictures they took of 3i? Yeah, I mean, the James Webb released the imagery showing the CO2 content and the water content in the comet. It was interesting to see all that. But you know what? The shutdown of the government caused us to not be able to see the images that had already been building up. You can see how bright the horizon's getting here. We are looking through clouds, so it isn't perfectly dark. I'm going to save this though. There we are. Chrissy Fishes from Western Australia. Very good. This is amazing. Thanks for the coverage. Of course, of course. Are you like over in, was it Perth? That region? We're looking for an Australian site for another telescope, actually. We don't have any money, though. That's something that we would do. Rascally Rabbit is here. Hey, Rascally says, I will return. Unfortunately, we're going to be closing up. If you notice, the daylight is coming, and we're going to lose our sky. Let's take a look at that sky, as I mentioned. So we come to the borrowed all sky we're using, and we're going to do this. And now you see the blue of the sky. See, guys? That's what's out there now. And we're still imaging the comet as the daytime approaches. Our filter is able to get rid of some of the blue, which is kind of nice. There we go. And I will save this, and we'll do one more series. And then the comet's gonna, this night, actually the daytime sky is gonna dictate what we actually get to see from that point forward. I'm sorry if I missed some of your comments out there. And Calb Sticky says, nice setup. Thanks. I'm getting rather sick of the explosion of AI generated videos of alien spacecraft invasion. Yeah, me too. It's such a it's such an exaggeration of the science, and I don't think it serves anybody at all. Josh says mainstream science has always been too quick to find his theories that have a limited testable capacity, ignorantly assuming physics elements, etc., in our world is the same everywhere. Everywhere we can see. Yeah, physics is the same everywhere. You know. Yes, in Perth, Chrissy says, "Oh, awesome." So you're what, 12 hours different from me? I'm at 8:13 here in Connecticut, but it's 6:13 a.m. out in the desert where we're viewing the comet right now. I'll save this again. I'll do one more series because it's still in the view. We're almost there. There we go. Comet's getting harder to see with the daytime sky. I wish we could see through the daytime sky, guys. I wish I could. Of course, I'd never get any work done. Well, this is work. So, you know. And by the way, Darius, thank you for subscribing. I saw your message up above. I just saw it now. Yeah, make sure you guys subscribe. You know, like I said, we don't charge anything. We're free. If you feel like donating, you can. But you don't have to. I don't expect it. You know, it's helpful if you do. Because we do have, you know, we have Starlink at both sites. There's the Starlink antenna. You can now see it pretty clearly there. We have it here. We have it in our Sonoran site. And that's $120 a month each site. So the telescopes, those are ours. We managed to get those through our own money we put in and through donations to get them. You only see one telescope in this setup right here. So let me look down at it right here, show you. That's looking over the top of the roof into the building. And let's see if the other guy is still doing his. Yeah, look. His telescope is still pointing up in the sky. Zip, up there. He's doing something too. He's doing photometry, where he studies the brightness of stars. And that tells us things. Okay, I'll save this. This is perfect. Because where I started from and where it ended allows it to stay in the entire frame until we can no longer see it because it's getting too close. The anti-tail is actually almost at the edge of the frame, which is neat. All right, let me clear. That's 5. Seems like 5 stacked frames. We take an image, align another one with it, and stack it on top and do that, make an image sandwich. Because it's moving so fast, we can do 5 and get a small motion blur in the nucleus. Josh says, we haven't been everywhere in the universe to physically test and know that the science is the same. That's the ignorance of speculation. I'm not being ignorant, and I may not be saying that, but what we know about the universe is that the elements and the structures in the universe that we understand are the same everywhere. Hydrogen is hydrogen. It's no different 10 billion light years away than it is right here. So we understand to a base level, we understand the construction elements, all right, of the universe. But as far as science, well, we thought, and we did have a science of comets, and our science isn't wrong. The science of the comets that are in our solar system is sound and correct, predictable, repeatable, repeatable results. But we also have to now account for extraterrestrial comets, ones that come that are interstellar, and that's what we're having to do now. This is, let's see if I can make this picture here worth it. Let's do this. That'll do a little better. Yeah, we're looking at more clouds right now. Yeah, I'll take an image of it anyway. Hey Karen, how are you? Nice to see you. Scarecrow Valley, what's going on? How you doing? Welcome. Yeah, we're getting some more morning light here. I'll just take one anyway. That's probably about the best it's gonna get, you know. All right, well, this is good. We went from here to here tonight, or this morning, and we saw Three-Eye Atlas, the closest it's ever gonna be to the planet. I hope you guys enjoyed that, and I am going to sign off for now. It's been a long night. Okay, last night was long. I had to go to New York City to do work at A&E Studios, and then I'm here. I did a show last night at 11 to midnight, and then got some sleep, and then got up early to show you guys this guy. So I hope you appreciated this and enjoyed it. And I'm going to leave you with Neo Slinky's comment. It's Santa Claus with his sleigh. So you guys have a good night. And by the way, this doesn't mean this comet's going away. We'll image it again. All right? Because it is going to be passing Jupiter up in March. So it's still hanging around in our solar system for a period of time. But this is about the brightest it's going to get. Okay? So there we are. You guys have a good night. And we'll talk again. So again, like and subscribe. Do become, members and join us. It's all free. If you want it to be free, you can give us anything you like, donate, help us with everything if you like. We have over 540 something streams up there that showcase objects of all kinds. So please enjoy them, and I look forward to seeing you all again. So you guys have a good night, and we'll talk soon. Bye everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Lift your eyes to the skies, universe in all its light. Sky tours bringing the view.